Hey, hello, everybody. Thanks for joining. We're going to wait another couple of minutes. I got caught up in Zoom authentication hell, so sorry for the delay. We'll be starting soon. First of all, hey, congratulate everybody. Today is the last day of September. You made it through the full month, so congratulations for that. Hopefully today's session will be well worth the wait. We shall see. Yeah, I think Zoom had my microphone all jacked up. Please let me know if you can still hear me. Blink twice. Okay, good to go.
Can you hear us? Kelvin, can you hear us?
Yes, yeah, pretty lightly though.
Interesting.
Today is going to be probably the most jam-packed session. We're going to be throwing so many things at you all. So as always, we'll upload the video in case you need to revisit it, because it's going to be a lot. We're going to be talking about quite a bit of things here. Going to be doing a little Kubernetes in case you've never seen it before. We'll be doing an install of Kubernetes, and we got to build a bunch of Docker images. We got to integrate into a network source of truth for dynamic inventory. We got a lot, so it should be good. Should be good. And just like, I mean, I got to give myself credit. I do this quite a bit. Like 5 minutes before we went live, I changed everything up. So should be interesting. We'll definitely have some live troubleshooting. I see it happening because I ran into some big issues right before we started. But all right, we're 3 minutes in. We're still going to have some friends come in over the next couple of minutes, and that's fine. We'll just I'll try to monitor the admission button, and we'll just go ahead and get started here. All right, today's session is hiding from me. Where are you at? There we go. Okay. All right, everyone, welcome. This is our September iteration of our monthly workshop. Again, we host these on the last Thursday of every month. This month I had just a little extra time because of the fact that the last Thursday of the month was the last day of the month. So hopefully you weren't kept in anticipation for too much longer than usual. Today we're going to be doing an interesting topic. This is one of my favorite topics. This is getting up and running with Ansible Tower or Ansible AWX, depending on how you like to refer to it. They are technically different, but they are directly joined at the hip, and we'll cover just a little bit about what the heck I'm talking about when I say that. But without any further delay, again, thanks everybody for joining us. This one's going to be an interesting one for sure. So we're going to give a little bit of background, a little bit of context in case you weren't available for any of the Ansible trainings that we've done in the past, or in case you were, but you just like a little refresher. We're going to spend just a couple of minutes refreshing what is Ansible, what are the core components of Ansible, and how does Ansible compare to Ansible Tower? And why do we say Ansible Tower or AWX? What's the difference? So with that, we'll, after we kind of lay the land as far as the the Ansible introduction, we'll just get right into the demonstration because it will take some time for us to get this environment up and running. And again, please sound off if you can't see the slides, but I'm going to assume that you can. So let's go ahead and get started here. Like we've discussed in the past, Ansible and actually all automation frameworks, not just Ansible, they typically have 4 major components that help us with performing automation in our environment. They do a very, very good job of handling some really core functionality that otherwise, if you were to build your own automation solution with Python or JavaScript or whatever it is, the responsibility for these core pillars would be upon your shoulders. And so what these 4 things are in the world of Ansible is, 1, there's a construct around inventory. And you might be like, yeah, well, no duh. I mean, of course there's inventory, but it's really, really important that you understand just how valuable that is for us. If you've ever written your own Python script, or if you've ever performed any kind of automation in the past, you'll know that in the networking world, we have more than one device. We typically have dozens, if not hundreds, if not tens of thousands of networking devices in our environment. And if you were to roll your own automation solution, the responsibility would be upon you to declare what those devices are, what's their host name, what's their IP, what version of operating system are they running. And again, if it's like maybe 10 devices, hey, big deal, right? You can statically type those things out. But if it's anything significantly more than that, the idea of managing inventory becomes very, very difficult and very, very time consuming. So the fact that an automation framework can help you not only manage the devices within your inventory, but also bridge over into a world that we call dynamic inventory, which basically means that you might have all of your devices managed by SolarWinds, for instance, or maybe all of your devices are inside of ServiceNow, or maybe they're inside of Netbox. The Ansible, what you can do with Ansible with the idea of dynamic inventory is you can simply say, hey, Ansible, all my devices are listed over at this IP address. Go and grab them and then return them back to me. And not only at the device level, but also you can create groupings within there. So inventory management, especially for us in the networking world, is crucial because, again, we operate in an extremely high scale in comparison to our brethren within other silos of IT. Now, another thing that Ansible does extremely well is they have this construct of a playbook. And a playbook is where an administrator such as yourself would actually declare what devices you would like to automate and what tasks you would like to have automated. Now, the nice thing about Ansible and the negative thing about Ansible, it's the same depending on who you ask, is that the playbooks are written in YAML. And I know that we've explored YAML a lot. We actually did a full video on data formats with XML and JSON and YAML, and we talked about it extensively there. But in case you haven't been able to attend some of these past sessions, what I want you to take away for right now is that YAML is just a text file. It's a data format that's basically a subset of JSON. They can be merged, they can flip back and forth between the two. So Ansible said, YAML is super friendly as far as humans go to be able to write these types of automation tasks. So Ansible is built around their DSL, or the way that you build playbooks is effectively based on YAML. Now, you don't need to really understand this, but just know that Ansible themselves sprinkled some extra goodies on top of what YAML can do out of the box. And that allows us to declare variables and pass in some types of logic. But the playbooks are themselves where we declare the execution and what devices to execute upon. Now, in any automation framework, it's not enough to just declare what you want to have happen. You actually need to have some kind of mechanism of interfacing with those network devices. In the Ansible world, we call these modules, but in other frameworks like Nornir or Scrapply or any other kind of network-based automation framework, they might be called plugins. But the idea is that there needs to be some heavy lifting to actually build an SSH connection to a network device or build a netconf connection to a remote network device, issue commands, handle the data that's coming back, et cetera. These workers are what we call modules in the Ansible world. And again, in Ansible, they're completely written in Python. Ansible itself is 100% Python underneath the sheets. So if you're ever interested in knowing how Ansible is making remote connections to your devices, you can just look up the actual source code for the modules. It might make your eyes kind of glaze over because not all of them are written very well, but at the end of the day, the modules are actually performing the heavy lifting. And the last thing that we talked about in the past around Ansible, just something to know about, is there's this construct of a configuration file. And that is there to allow you to override some of the defaults that Ansible ships with out of the box. This is extremely important for us in the networking space because, in all honesty, Ansible was not built for us. And to be completely frank, Ansible was kicking and screaming to actually get to prevent networking support within the product. Now, this was years ago, so the tides have changed. Everyone's come around in the networking world to say Ansible is the de facto for network automation. But it's important to know that, again, Ansible was primarily built to manage servers, specifically Linux servers at the time. And so there are some defaults that ship with Ansible that are no fly with networking devices. So the configuration file allows us to override some of the defaults of Ansible to make it play along a little bit better with the networking devices themselves. All right. Actually, I got some examples of what each one of these 4 components actually looks like in the construct of an inventory file. This would be if you're statically managing your inventory in a file. You can manage it as YAML, as we see that's listed out here on the left-hand side, or you can manage it in an older format called INI. Both of them are perfectly acceptable. But here you can see the relationships of each of the devices based on where they're nested in the environment. So you can create groups, you can create devices, you can assign certain variables to devices. So in this case, I'm assigning static IP addresses to my network devices themselves. But this is the file that Ansible will look for whenever you're executing your playbook, so it knows which devices to actually interface with. Now, the playbook themselves is it's pretty straightforward. It's based inside of YAML, so everything is, you could probably hand most playbooks over to someone who's never seen automation before, and they could probably piece together, at least at a high level, what's actually taking place, especially if you leave really nice descriptions like I try to inside of my playbooks that help the users understand exactly what's going on. So we'll definitely revisit some of these playbooks, but I don't want to make this an Ansible introduction course again. We've done them quite a bit up until this point, so we're just going to be focusing on Ansible Tower for this one. The modules, as you can see, they're referenced here. In this case, I'm running one of the official supported modules that are provided by Juniper. This one's called Juniper Junos RPC. This allows us to perform a remote procedure call or an RPC over the netconf API on the Junos device. And if those words don't make sense, I would highly recommend that you revisit some of the past sessions on netconf for that. But fairly easy to actually read. And so this is why Ansible kind of defaulted to leveraging YAML for the markup language, because it's pretty easy to manage and support. And the configuration file is in the classical kind of INI format, or at least within the Ansible core product that we're looking at here today. And again, this just allows us to override some of the defaults. Some of them are basic, like with SSH. You know, anytime you built an SSH connection to a network device that your computer has never seen before, you know, you get a prompt that'll say, hey, here's the public key of this device. Do you accept it? No, I bet no one on this call has actually ever validated that. But in this case, some of the defaults that I typically roll with in Ansible is I disable host key checking, so I don't get a prompt, and I disable or I enable a feature that will automatically add a device's public key to my local authorized hosts on my machine, so I'm not ever prompted again. We're not going to get into all these configuration variables, but hopefully that helps at least kind of refresh everybody that Ansible performs certain tasks extremely well, and the framework itself of Ansible has these 4 main pillars that allow us to actually build automation to help configure and manage our networking infrastructure. Now, with that, let's talk about Ansible Tower and where it differentiates with, and why I keep misusing the word Tower when I really mean AWX. So let's first talk again, the core features of Ansible, hey, they're still there. They're not changing at all. They are built within this, this GUI product that we call Ansible Tower. Now, what Ansible Tower or Ansible AWX, what it actually provides to you that's different than the core Ansible is, one, there's a web user interface. So it's a Python web application that anyone can visit and manage their network automation by leveraging a web browser like Chrome or Firefox or whatever floats your boat in that domain. So having a web user interface, I cannot overstate how important that is as far as getting automation adopted within your environment. It's crucial that your team has a really low barrier to entry to getting up and running with Ansible. And so having a graphical user interface rather than expecting everyone to use the command line utility is extremely beneficial. In addition to the web user interface, you also get a REST API, which is, honestly, I would say of all the features, for me personally, this is the best feature of Ansible. And it's one that the other automation frameworks out there are still in desperate need of. So frameworks like Nornir and Scrappily, they're completely command line based. And so there is no REST API. So if you ever wanted to build an integration between Ansible and Slack or Microsoft Teams or ServiceNow or PagerDuty or whatever software that you have in your environment, that software is going to expect that there's a REST API that it can interface with. So the graphical user interface, Ansible Tower or AWX, does provide the REST API to actually help you build really intuitive integrations. There's also a really robust authentication service within Ansible Tower. So your traditional AAA Radius or Active Directory backup, or I'm sorry, Active Directory for authentication, as well as user permissions and groupings and roles. So obviously, if you're going into production with an automation framework, these are the types of things that, you know, if you don't have them kind of laid out, then your corporate auditing team is going to be knocking at your door saying, wait a minute, what's going on here? So super important to have user authentication. That's another great thing that Ansible Tower is going to provide for us. And the other one is also really powerful, especially for any kind of security role, is that we have an audit log as to who executed what playbooks on what device and what was the result of that execution. So if Ansible Tower is not inside of your environment and Ansible is just being ran on everyone's laptops or their workstations, nobody knows really who did what against what devices, because it's not like in a centralized location. It's everyone's got their own history on their own workstation. So having an audit log is extremely advantageous. Now, let's talk really quickly before we get into the demo about why I keep saying AWX and Tower and where do they differentiate with. And if you're unfamiliar, if you don't play into the Linux world too much, let me just kind of set the stage a little bit. You may have heard about an operating system called Red Hat, or RHEL, Red Hat Enterprise Linux. RHEL is like the de facto enterprise Linux for most organizations today. Red Hat provides support. Well, it comes through IBM these days, but you get the idea, right? It's a supportable Linux operating system. Now, all the development for Red Hat or for RHEL operating system is not built within RHEL. The developers for RHEL actually use a different, what they call an upstream release. And as of September 30th, 2021, that is now what they call CentOS Stream, used to be CentOS 8. Before a year ago, I would have told you it was an operating system called Fedora. Don't worry too much about where the development for the operating system goes. I just want you to know that there's a supported version of Red Hat Enterprise Linux where it's rock solid and you pay for the support from Red Hat. And then all the development for RHEL goes in an upstream release that they call either CentOS or Fedora. Now, the same applies here with Ansible. Surprise, surprise, Red Hat owns Ansible, so they're following a similar mantra. The supported graphical user interface tool is called Ansible Tower, and you pay, well, they've been trying to get the licensing right over the last couple of years, but the last I checked, you would pay per device an annual subscription, and it can get to be pricey, right? Again, networking engineers, we're technically managing hundreds of thousands of distributed systems across our environment. So you can imagine that the licensing gets kind of sketchy, or I'm sorry, it doesn't get sketchy, but it gets pretty expensive. So, so what Ansible will do is that all the core development for Ansible Tower goes in an upstream release. And that upstream release is completely open source and available for anyone to consume, but it has a different name. Just like RHEL uses CentOS and Fedora for its upstream development, Ansible Tower uses AWX. And if you're on a budget like I am, AWX is really the only way to go, but it's also a very great way of getting the idea, the concept of Ansible Tower within your organization. You can spin it up in a lab environment. You don't need to worry about licenses or support or any kind of contracts like that. You just spin up Ansible AWX. You're going to get every feature that Ansible Tower already has and more so, right? But you have to know that you're not going to get support outside of the open source community. And yeah, that's the big, oh, and you're technically running, you know, a bleeding edge release. You can find a more mature version of AWX, but that's typically not how people will deploy it. So you will be on the front line. You'll be the one finding any bugs should they exist, and they will. So that's why I use the phrases Ansible Tower and Ansible AWX interchangeably. They are, again, they're technically separate products, but the way that they're packaged and the way that they're available to us consumers differs greatly, right? We don't need to sign any kind of contract to get up and running with AWX. So I'm going to continue to use the two phrases back and forth. I'm going to ask you to just bear with me. When I say tower, I mean AWX. When I mean AWX, I actually mean tower, and it's all good. For the demonstration today, we will be using Ansible AWX because this is, you know, what I'm running with in my environment. The packaging used to be different. I don't know if it is today, but Ansible Tower used to be just like a shell script that you would install on your machine, on your Linux machine, and it will provision all the systemd services and firewall services, etc. Whereas AWX was always container-based. Now, this is a really interesting point, and probably the reason that I'm doing this session today is that within recent months, Ansible has completely changed the way that they package AWX. Whereas before, you would pull down the repository for AWX, you'd pull down the source code, you'd tweak a couple files here and there, then you'd issue a command and it would actually use Ansible to provision all of the containers, get everything up and running, get the web service talking to the database, et cetera. And then you'd be off to the races and not looking back. There were significant problems with that. And we'll revisit this later when we talk about execution environments. But just know that Ansible was not really happy with some of the limitations of the way that it packaged the system itself. So what Ansible did is they said, okay, we're going to rip out the Docker support. We're still going to run this as containers, but we're going to be running this within Kubernetes from now on. Now, again, a lot of really great reasons and a lot of really powerful benefits from doing this. However, Kubernetes is not really for the mortal people like you and I. It's a monster. It's a behemoth. Even for someone that plays in the container space day in and day out, it is a difficult system for sure. It's incredibly powerful, but it requires a full career to actually be proficient with it. So what I wanted to do today is to help you figure out what it's required to actually stand up Kubernetes to be able to install Ansible AWX and actually run through the getting up and running with it, creating organizations, adding SSH keys, pulling in your playbooks, etc. And so that's what we're going to focus on today. All right. So that's it for the PowerPoint. I do have some backup slides, but let's just show you what the end-all solution will look like when we're done today. We're going to be standing up Ansible AWX from scratch. That's the Kubernetes, that's the whole run. We're then going to build integrations into Ansible so that it can receive inventory from my network source of truth. Now, this could be, again, SolarWinds, ServiceNow, anything in your environment that has an API. In my case, I'm going to be using Netbox because it's by large the most common network source of truth tool within the environment. We'll be also interfacing with GitHub so that we can pull down Ansible projects and also to store some of our Docker containers. Now, for those of you that were on the call when this session first started, I mentioned that I made some last minute changes that ended up breaking a lot of things, and it was the GitHub side. And that's because I don't use GitHub all the time. I typically default to GitLab. So this might, if we run into problems, I might scrap the GitHub and just move to GitLab. It shouldn't be a problem. I just managed to find a problem with it. So we'll see. And then we'll also configure a network device to allow for connections from Ansible Tower or AWX. And really the only thing I'm going to do there is I'm just going to create a user account on the network device itself that Ansible Tower can leverage. And we'll be using SSH keys for authentication because nobody likes to type passwords, and especially the automation stuff. So before we get started, we got some stuff in the chat. Rocky for the win. Yeah, so yes, Zach. So Rocky Linux is the logical replacement for CentOS, CentOS 8. The instance of Ansible AWX that I run in my home is based on Rocky. Rocky is fantastic. However, I ran into a bug with Rocky this morning where I couldn't pull in a specific repository, and just the whole Kubernetes thing fell on its face. So I'm not going to be using Rocky for today, but I would highly recommend any of the Red Hat fans or CentOS fans to give Rocky a fair shot because it is a fantastic Linux distribution. All right, so that was 5 minutes of introduction that took 30 minutes. I apologize for that. I tend to get pretty excited about this stuff. Let's go ahead and SSH into our AWX host. And I think it's AWX 3. and enter my password here. Yeah, and so this is CentOS Stream, which is the upstream release for Red Hat, where the development of Red Hat goes in. And I just want to use the history command to show you all the things that I've done up to this point, just so that you know that there's nothing up my sleeve. I'm not staging anything ahead of time. One thing I did is I added myself to the super user through vi sudo. I did some updates to make sure I had the latest packages. I disabled firewall D because I hate firewalls that run on Linux servers. I also disabled SE Linux because that is one of the biggest banes of my existence. And these two, I believe, are also the recommendations for Ansible AWX. I know this one is for sure. Maybe I'm the only one that disables SE Linux. And I set the host name, set an IP address, and rebooted the system. So that's basically all we did. All right. So the very first step, let's move that over here. I've got a little cheat sheet here. I'll be sharing this with you later as well of the commands that we're going to be running. But the very first thing for us to do is actually get Kubernetes up and running. So let me pull out my fancy cheat sheet here. Go to my, let's look at my activity. Let's move to my groups. We'll be looking into this one. And then for public presentations, such as this one, we'll go to content creation, the public, and Ansible Tower. The dirty secrets, I'm staging everything ahead of time. All right, good to go. Now that I got my cheat sheet here, the very first thing we need to do again is to install Kubernetes. So this is like right out of the gates, I'm already at odds with the official recommendation from Ansible. So let me talk about this for a second. If you visit Ansible's documentation, we'll pull that up while we install Kubernetes in the background. If I just type in Ansible AWX and go to the GitHub, there are instructions to getting up and running. You have to know which link to click. It's this one. Here's where I differ with Ansible. They recommend, actually that's the wrong one. They recommend, where are they going here? They recommend that you install Minikube, and I highly encourage you to not do this. Minikube is okay if you want to get off the ground and running with Kubernetes on your local machine. But if you need anything, if you need anybody else to access your environment, Minikube is not really the right tool for that. It's great for local testing, but it does require you to run Docker within your home environment, which you might think might not be that big of a deal, but unfortunately, Docker is flirting with some really dangerous licensing, and so effectively, Docker Desktop is can be paywalled depending on what company you work for. It's ridiculous. So I highly encourage you to not use Minikube and instead consider installing Ansible on a Linux server like what we're doing here. Now, this can be a Linux virtual machine running on VMware or VirtualBox. That part doesn't really matter. Just don't use Minikube and instead use what we're calling K3S. Now, K3S is a Kubernetes. It's not K8S, it's K3S because there's just 3 letters. Get it? But this is a fully supported Kubernetes install by a company called Rancher that was recently acquired by another Linux distribution called OpenSUSE. Rancher is phenomenal, probably one of the best ways of packaging Kubernetes within your environment. You saw that all we had to do to install Kubernetes was run this single command right here, and that actually got Kubernetes up and running within my environment. So with that, let me elevate my permissions here by typing sudo su and then dash, and you can see let's just kind of clear the screen so that you can get a little bit more clarity. My username had changed from my personal username to the root user. So now I have effectively King Kong access into my environment. And just to make sure Kubernetes is up and healthy, we're going to be running a bunch of kubectl commands. Now, kubectl is the way that you interface with Kubernetes. This will not be a Kubernetes course. If you are interested, though, please let me know, and I'll definitely get one up and running for us. But in this case, we can see the nodes in my environment. I have a single node, and it's the local node that I'm working on. And we can do kubectl get, or actually version, and I think it's short, and that'll tell you the client server version. So in our case, we're running Kubernetes version 1.2 or 1.21.5. So we're good to go. Now, the next thing that we need to do is we need to download something called an operator. Now, this is a really awesome construct that lives within Kubernetes. And let me hit the git pods-a here. This will take a while. We can see that there's a container being created. What actually happened is that there's a file out on this URL. Let's go ahead and open up a web browser here and look at what that file actually looks like. So this is a really long file. You don't have to know any of this, by the way. But at the end of the day, this is a series of instructions that Kubernetes can ingest to get something off the ground and running inside of your Kubernetes environment. In our case, what we're deploying is something called the AWX operator. And all an operator is going to do, for the context of today's conversation, is manage Ansible AWX. This is the actual container that will build AWX for us in our environment. It's not AWX itself. It's basically a series of Ansible playbooks that are stored within a container image, but the operator is what's going to be the mechanism that we use to deploy Ansible Tower. So again, we just ran this single command, and it went ahead and instructed Kubernetes to download this container. Let's go ahead and check up on that. And it says that it's running. That's awesome. Let's go ahead and look into the logs really quick by saying kubectl logs-f, and then the name of my container that I just copied here. And here we can see that Ansible itself has got some things going on, or it did, but it's effectively not doing anything right now. It's just standing by, waiting for us to pass our next series of commands into it. So let's go ahead and do that now. What I need to do is I need to create a file to give it some basic information about how my Kubernetes environment or how my AWX environment should be defined. And then we'll pass that file into the operator, and then that will go ahead and stand up Ansible for us. So let's create a YAML file. I'll call mine AWX. It could be called master P for all you care. It doesn't really matter what it's called. As long as it ends in a YAML or .yml, you're good to go. And I'm going to pass in some basic parameters. Let's go back to our PowerPoint presentation and look at what those parameters are. So in this case, this is the configuration that I need to pass into my YAML file. Oh, and I made that an image, so I can't copy and paste it, but I do have it somewhere else. Let's go ahead and paste this in here and make a little bit of modifications. So if you haven't played in the Kubernetes world, you might not know this, but this is effectively how you define resources inside of Kubernetes. You declare them inside of a YAML file. You got to make sure you pass all the right arguments, but this is effectively how you would build a load balancer, or you would build a virtual machine or a container image or whatever it might be. And so for us now, what we need to do is we need, again, to pass in the Ansible AWX file into the operator. The way that we're going to do that, we're just going to say kubectl, and we're going to say apply-f for file, and then the file that we just created. All right, and this is going to take about 9, maybe 10 minutes in all for it to actually instantiate. But if we revisit the log file, remember how it was just kind of chilling out there, nothing really was really going on. If we now revisit that operator log, what you'll see is that there's a whole lot going on. So the operator has now ingested that awx.yaml file that we created, where we just basically defined what's the host name, what's the domain name. and it's passing that into the operator. And now the operator is going to go ahead and stand up Ansible for us. So there's a lot of things that are going on here. There's load balancers that are being instantiated. There's databases that are being instantiated. There's web services that are being instantiated, all these different things. This will take about, again, 9 or 10 minutes, but fear thee not, we have quite a bit of work that we need to do while this is running in the background. Now, I talked quite a bit about Ansible and how it's built around Python and how that affects, how that architecture ultimately led us away from like the Docker-based deployment into a Kubernetes. And this is a really great time to kind of revisit it. So as we discussed in our last video and some of the previous ones on Python, Python ships with almost every Linux distribution, with every FreeBSD, a Macintosh, etc. Python is built within the operating system because the operating system requires Python to do some of its traditional tasks. The reason why that's really important to know is that the system itself has very specific versions of Python packages that it's expecting to have. So if you went in and you started to say, hey, I need the Juniper's PyEasy package and I want to install it on my computer, there's a high likelihood that the version of packages used in PyEasy will override some of the Python packages on your host operating system, and you can effectively brick your computer. Not a fun way of going about doing it. And yes, there are guardrails within there. But when we moved over and we started deploying things inside of Ansible AWX, we had to create these Python virtual environments inside of AWX so that we could do things like install the Juniper Python packages, to install Cisco packages, to install packages for Palo Alto, whatever your network vendor of choice is. But we had to do it within this construct of container or virtual environments. And the fact that AWX was running in containers meant that you had to log into containers and kind of hack your way through to build these new virtual environments just so that you can safely install Python packages without breaking the system. Now, that was a terrible implementation. I understand, yes, it was a necessity at the time, but it really made life difficult, especially when you're in a production environment, to have to SSH into the Ansible host, then get into the container, then get into a virtual environment, and then just do this magic. It was a big hassle. So when Ansible AWX moved into the Kubernetes world, what you can now do is you can build your own container images for Ansible to execute, which is great because now we can just stuff all the packages that we need in a dedicated container image. And then we're off to the races and running, just telling Ansible where to find that container image. All right, so a lot of things going on there. Python system dependencies and virtual environments and all this crazy stuff. What we're going to do now is we need to build some of these containers that Ansible is going to leverage to actually execute things. And we need to build two separate images right now. One is a container image that will be able to talk to our network source of truth. And then the second one will be a container image to interface with our Juniper network devices. Before we go, let's see, we got some chat. Netbox or Autobot? So I'm running both. Both are fine. Friends of mine are running the Autobot project. I wish them all the best. I love those people over there at Network to Code. I'm going to be leveraging Netbox in my environment, mostly because Netbox has recently adopted JavaScript for a front-end user interface, and it just looks so much better and it responds so much better than the previous iteration of it. So we will be using Netbox in this case, but just so that you know, and we've done a session, we actually brought Network to Code in to talk about Autobot. They're based around the same project. So whatever we do for one will work for the other in effect. So let's check in on our Ansible deployment. Looks like things are still going on over here. That's fine. Let's start building out these Docker container images that will be used for the execution. And by the way, Ansible Tower calls these execution environments, or so you might see that used extensively here. I'm going to SSH into a new server here. There's not a whole lot going on yet. Development. Okay, so I've got a directory here that will handle our Ansible execution environment. Let's look into the Ansible-EE Junos, and let's just take a peek at what we have here. I'm going to remove the context directory because that's I don't want to give it away of what's actually happening. But Ansible, they ship something called Ansible Builder, which will allow you to build these execution environments. And so let me activate my Python virtual environment, and we'll go ahead and we'll build out this new Docker container to handle our Ansible Tower execution. Just so that you know what this actually looks like, the YAML file that declares this container is just a few commands. You're basically telling it which Python packages to install from the requirements.txt, and then we're telling it which Ansible collections to install based on requirements.yaml. And if we just peek into requirements.txt, you can see I've got 3 different Python packages installed or selected to be installed into this Docker container. One is the Junos EasyNC, which is Juniper's PyEasy library. Another is JSnappy to help us do snapshots on Juniper devices. Another one is JXML Ease, which simplifies the XML interaction within those projects. So with that, oh, and the requirements.yaml, where we actually just declare the Ansible collection that we're installing. In this case, it's called juniper.device. And so for us to execute this, we're going to say Ansible, let's see, I think I actually have this in my history here. History grep builder. Yeah, we're going to run this command right here, Ansible-builder. We're going to tell it to build, and then we're going to tag a Docker container image. Now, I'm not going to use this image right here because this is for the GitHub repo. This is where I was running into problems earlier when I was trying to store this Docker container on GitHub. So we're going to leverage GitLab instead for our example today, just because I know that GitLab will work without any kind of heartache. And so let's go ahead and create a new repository over here. And this will host our Ansible Docker containers. And I'll call this Ansible EE Junos, EE just for execution environment. I'll set it to public, and sure, we'll initialize it with the README. And what's great about GitLab is that you can also store container images very easily. So for us, we're going to say we're going to build this image right here with this name. Okay, right there. So again, we're running through the builder of Ansible, which will allow us to build this Docker container image. As you can see, it took no time at all to actually build it. It's because I did it ahead of time, so it's already staged. But let's go ahead and push this container image up into to GitLab. And to do that, we're just going to copy this command down here. Oh, actually, this should fail because I have not logged into my GitLab. So let's do this. Let's log into my repository. And I'll pass in my super secret username. Wrong. All right, and let me hide my password. I think you guys are all really cool, but I'm not going to share my password with you. I hope you don't get too upset about that. There we go. Login succeeded. Now let's push that container image back up. And so we've talked a little bit about containers in the past, not to sweat it too much right now. There's effectively different layers within a container image based on the instructions you pass in a container file. We didn't have to worry about any of that because the Ansible builder actually took care of that for us. While we're pushing the image up, let's look into our AWX, and it looks like our AWX installation was complete. All right, so now what we'll do is we need to actually find out a couple of bits of information from the Kubernetes environment. The first one, we need to figure out what port Ansible is actually listening in for, Ansible Tower. And the way that we're going to do that is we're going to say kubectl get service, SVC. And you should know, being a network engineer, anytime you're talking about Kubernetes or anytime you hear about Kubernetes and they use the word service, what they're really meaning is network, right? So this will be where all of your ports, your IP addresses, et cetera, are taking place in. Now, in my case, what we have is Ansible itself, Ansible Tower is listening on port 80, but this is only available within the VXLAN overlay of Kubernetes. Yes, Kubernetes uses VXLAN to build all the networking within itself, within the cluster. That's how you can scale out to distributed systems. Now, so what we need to do is we need to find the public facing interface that this is being port address translated to. In my case, when I ran kubectl get service, I can see that the listening port is 31941. All right, so let's go ahead and visit our web browser. I'm going to type in awx3.dmz.home and port 31941. And yes, we are getting the login page now for Ansible. Now, another thing that we need to do is we need to find out the administrator password because it's generated on demand whenever AWX is being built, and it's encoded in base 64. So you need to be able to decode that. So let's take a look at the passwords that are managed by Kubernetes by saying kubectl get secret. I think it's, let's try get secrets. Yeah, that worked just fine. So the secret that we're looking for is this one right here, the one that says AWX admin password. Now, the way that we get the Kubernetes to decrypt or undecode the base 64 encryption on this password encryption on it, we're going to say kubectl get secrets, or get secret, in this case, AWX3 admin password. Now, if I just entered that alone, it's just going to tell us, hey, yes, this Kubernetes secret does exist. What we wanted to do is actually print the output to the screen. And the way that we do that is kind of weird if you haven't worked with Kubernetes before, but we need to say -o for output. And then we're going to say JSON path, and we'll definitely revisit this just in a second. But let me just go ahead and open and close some parentheses and some curly braces. And then we're going to do base 64 -- decode. And within here, I need to tell it exactly where within the secret to find the password, because the secret itself is structured as YAML as well, or I'm sorry, it's structured as JSON. And so we're going to say .data.password. It's kind of weird. I agree, but this is how we get secrets out of Kubernetes. And only users with root password would have been able to actually achieve this. So don't worry about that admin password being leaked out. So this is the string that was returned back. There's no way in heck I would have ever guessed that. So thank you for Ansible for providing that. Let's try to log into our Ansible environment. The default username is admin, and then we'll just paste in the string that we got from the decode and hit login. Now, we're going to be greeted now with our Ansible AWX environment, and there's nothing here whatsoever within the environment. So this is a really great starting point for us. So again, really just to summarize where we've been thus far, we've started with a Linux server with really nothing going on it. We installed Kubernetes by pulling down that Rancher shell script, which automatically installed K3s, which is effectively Kubernetes. And then we deployed an operator. The operator itself doesn't do anything. It requires you to pass in a file. We created an AWX YAML file where we declared some basic parameters about our environment, specifically the host name. And then we deployed AWX by passing that file into the operator. We held our breath for about 9 minutes, and then AWX is up and running. We had to find the port that I was listening to by doing the kubectl get service that told us what port address translation is taking place. And then we also had to find the secret password for the admin user by decoding the base64 and coding on the password that was generated for us. But with all that said and done, we're now inside of an active and a working instance of Ansible AWX. We will return to the execution environments very quickly, but for now, let's just kind of get ourselves familiar with the user interface. So the way that the interface is structured is on the left-hand menu, you have your hamburger menu right here that you can collapse. The views that you'll predominantly be spending a lot of time in, when you log in, you're going to get the dashboard. You're not going to avoid that. But the jobs panel is where every single execution of Ansible Tower will show up in a historical fashion with the most recent job on the top. So you'll be spending a lot of time in the jobs so that you can revisit what's actually executing successfully. Not so much with some of these others, so I'm going to ignore them for now. Inside of the resources, this is where you associate like a GitHub project or a GitLab project. This is where you build out what they call templates, which you can just, if you had to like understand, whenever you see the word template, just think playbook. It's technically a playbook with a little bit of extra that's sprinkled on top, but at the end of the day, playbooks are called templates inside of Ansible Tower. It's a point of frustration for me that they could not keep the same terms used. And I do recognize that they are technically a little bit different, but it's all about the user experience, and renaming things differently is a little bit confusing. Credentials, we're going to be spending a lot of time here, almost right out of the gate. This is where we'll create our GitHub credentials so that Ansible Tower can pull down repositories. We'll create credentials to log into network devices. We'll create credentials to interface with container registries, with Ansible Galaxy, all these different things. We'll be spending a lot of time with credentials. The projects themselves, these are your source code repositories on GitHub, etc. Inventories is exactly what it sounds like. These can either be statically declared within like a YAML file or INI, or in our case, we're going to be pulling in from Netbox for these. And host would be the summation of any of the inventories that are declared. Access is going to be our first place that we visit, where we set up users and accounts and roles and permissions, etc. Administration, not going to be spending a lot of time in these outside of execution environments. This is the containers that will be doing the actual heavy lifting. These are the containers that we're building so that Ansible can do the heavy lifting. And settings is exactly what you would think it is, right? Traditional miscellaneous settings for Ansible Tower. All right, so let's go ahead and get started by creating ourselves an organization. I'm going to create a fictitious organization called Redtail Consulting, and that's all I need to do. So I'm going to create the organization, and then I'm going to create a user. And let's go ahead and create our first user as, let's just use my traditional name here. Oh, my first name is Calvin Remsburg, and here's my email address. Please don't hack me. Zach, I know you're looking at that email address. Please don't hack me, sir. All right, pass some username and password. You'll note that as the passwords get typed in, it's hashed. You don't actually see it. You could click the show button, but you could only click this once during the setup. You cannot revisit a username after it's been edited or after it's been created and revisit what that password was. I'm going to give myself King Kong access here, And I'm going to say I belong to the Red Tail Consulting organization that we just created. And save. Now, if I wanted to, I can go ahead here and create a team. This might be like my network operations team, my network automation team, maybe systems teams, etc. Teams obviously help with permissions and that type of association. But for what we're covering right now, there's no really no value in visiting teams at all. So for us, the next logical step for us to do is go out and start building some credentials. And the first type of credential I want to create is a SSH key that's going to allow us to authenticate to our repository. This could be GitHub. In my case, it's going to be GitLab. So I'm going to call this GitLab. Yeah, just going to call it GitLab, nothing fancy. And I'm just going to remind myself which account I'm binding this to by adding in my email as a description. And again, this will belong to the Red Tail organization. Now let's look at all the credential types because there's quite a bit. So Ansible, right out of the gate, Ansible Tower ships with a lot of different mechanisms for it to authenticate into services. Things like AWS, Ansible Galaxy, which is like a repository for Ansible collections and such. Container registries for like Docker Hub, or in my case, GitLab. There's some GitHub personal accounts, personal account tokens, HashiCorp. If you use any HashiCorp Vault, which is one of the greatest products out there to manage secrets, you can store them here as well. When you see machine, just think Linux or Windows machine type of credentials. And then network. Network is for us. This is to authenticate to a router, to a switch, to a firewall, these types of credentials. Now, the first one that we said we want to create is GitLab. So I'll look at that source control. And I will pass in my username that is required for me that I use to log into GitLab. And I'm not going to pass in a password. Instead, I'm going to pass in my SSH key. This will allow me to authenticate without passwords. So it's inherently much safer. And I'm just going to, on my Mac, hold down Command Shift and press the letter G and tell it to go to my SSH directory. And the SSH key that I need to upload, remember, SSH keys are generated in pairs. There's a public one that can be shared by anyone, and it doesn't do much outside of that. Then there's the private key that needs to match what the public key unlocks. So what Ansible AWX is looking for is your private key of the pair. So in my case, I'm going to go ahead and select my system's private key. And let me just make sure. I think that's going to be right. And there's no private key. There's no passphrase on mine. All right, there we go. By the way, don't worry, all these keys are temporary. So by the time this video gets uploaded to YouTube, they'll all be regenerated. So don't even bother typing in all those all those that big long string of text right there. All right, so that should be enough for me to pull down a repository. Let's log into GitLab and look at some Ansible examples, and we'll try to pull down a repository. Let's look at this one. It says configure with CLI. That one might be good. Let's look at the retrieve configuration. This is an Ansible project that I think just pulls down a config. This will just pull down a configuration and write it to a file. So this is a good starting point for us to not only validate that that Ansible AWX can pull down the repository, but also for us to actually leverage within today's demonstration. Let's pull in the retrieve configuration, and I'm going to say clone, and I want to clone with SSH. Remember, we just uploaded our SSH keys. So now let's go ahead and test that out. I'm going to click on the copy URL, and now we'll go to our first project. And what we're going to do is we're going to call this Junos retrieve configuration. And the description for this project, this will retrieve a configuration. Yeah. And then the organization is going to belong to the red tail. So again, if you have multi-tenancy requirements, if you have a firm demarcation between organizational units in your company, these will be extremely advantageous for you to allow namespacing within the product. I'm going to avoid the default execution environment for now, but when it asks us for where the URL is for our project, I'm going to tell it that we're going to do this pull through Git. And then I just need to paste in the URL that we had copied from our repository up here. Now, I also need to pass in the source control credential, and that's why we created the source control credential before. So let's go ahead and click that spyglass and click this and say select. And you can see that we have some options that are listed here. So just so you know, I see a couple things in chat. We'll get to that in just a second, but I want to go over these options here. Clean will effectively discard any changes that you've made for this project inside of the Kubernetes cluster. You'll probably never need to ever visit this one. Delete will delete any cached version of this project inside of your container. So anytime you execute a playbook inside of AWX, you can have AWX say delete the last time that delete the project from the local file system and then pull down a fresh copy. And then update revision on launch allows you to control how long Ansible should wait before pulling down the project again. This is advantageous. Like if you don't want Ansible to pull down the project every single time, you just want to keep it local, but you want to have like a timeout value on that local copy. This is where you have the opportunity of saying, hey, cache this for 600 seconds, right? Or 60 seconds. So it only pulls every minute or so. I'm going to leave these all off, which means that I will have to manually refresh my local project inside of AWX if I ever want a new copy. And I'm okay with that. We'll go ahead and click save, and it's going to go ahead and try to clone the repository from GitLab. Now, if there's a problem with my SSH keys, this is where we'll see it. The job status will come back and it'll say, hey, we tried to clone it, but there's a problem with your key. There's a problem with your authentication. In our case, we see that the poll was successful. All right, so let's see what chat is. Zach says I can read asterisks like him in the Matrix. Yeah, Zach, I'm pretty sure that you do live in the Matrix. Sean asks, why were those commands for pushing the image Docker commands? Why were those commands for pushing the image Docker commands? I think you're talking back into the GitLab repository here, like under the container. Let's look at our activity. There we go, right here. And inside of the container registry, well, here's the CLI command. So we constructed a Docker container for this idea of an execution environment. Again, we were just about to get there inside of AWX, but we wanted to build a container on our local machine that has all the dependencies required to interface with a network device. Now, we need to push that container somewhere because Ansible is going to be looking to pull it down. So it needs to be accessible by Ansible Tower or Ansible AWX. Now, you could use Docker Hub for that. Docker Hub was for a very long time like the de facto place to store any of your personal Docker container images. I personally have a lot of question marks about the future of Docker as a company. And so I don't really want to invest in really anything that they're doing these days. So I'm not using Docker Hub. I'm instead going to be using GitLab as the place to store my container images. And you can use GitHub if you want as well. I just ran into problems before we went live today. So I'm just going to default to be using GitLab for my instance. So the two commands that we needed for us, one was to log in to my container registry, which in my case is GitLab. So I definitely needed that command to pass in my username and password. And the second command I needed to do is I needed to be able to push the image that we generated back up into this repository, which is what we see right here. It was successfully done. Now, the reason I didn't need to use the build an image command is because that's precisely what where did it go? That's precisely what we had done with the Ansible builder command previously. Good heavens, Calvin. The Ansible builder command that we had, I don't know where it went. It's in my terminal over here and right here. So when we built the container image with this Ansible builder, that was effectively doing the role of the second command that was listed there. So Sean, I hope that helps answer your question about the two different Docker commands that we were using there. All right. So yes, thank you. All right, you're welcome. Keep them coming. So now that we've created the project, so we've got our GitLab project now available inside of Ansible AWX, we will have to, well, let's go ahead and let's create the template. Again, remember, when I say template, just think playbook. It's effectively kind of the same thing. Just again, with just a little secret sauce splashed on top. So let's add a job template. And we will call this retrieve configuration. And the inventory, I'll just default to the demo inventory for now. That's fine. The project, this is where we tell it which GitLab or GitHub project to pull from. In our case, we really only have one, the one that we just added. And then now when I select the project, Ansible will ask us which playbook do you want to actually execute. Now mine is kind of nested down in here. I'm going to pull out this one right here called in a directory called files, Ansible playbook config download.yaml. That's going to be my playbook. Now it's going to ask us what's the network credentials to log into our devices. And if I move over to network, I see that I've got none. So I'm going to leave this blank because we're not going to execute it just yet, but know that we're going to have to revisit two different sections in order for us to execute this playbook. One, we need to revisit the credentials to create our network login. And the second is we need to upload our execution environment. And we'll get to that as well. That's the execution environment, again, is the container image that we're building that has all the Docker, has all the Python libraries to interface with our devices. But for now, we'll go ahead and click save and say we are good to go as far as the template creation goes. I can't execute this successfully just yet because we're missing some things. Let's go ahead and revisit credentials, and we'll make a new network login. We'll call this AWX and username AWX, and login will be with SSH keys. And the organization, again, will be the one that we had created. The credential type is going to be network. And we're going to say the username is AWX. We're not going to use a password. Let's create a new SSH key pair to use to log into our devices. So we'll come back to our terminal here. We'll clear our screen. Let's create a new SSH key pair. So SSH keygen -T RSA -B 4096 for the bits, and C to pass in the name of this key. In my case, it's going to be AWX. It's technically a comment. And it'll ask us, where do we want to create this? I'm going to say in home, c.ssh, and AWX. Not using any passphrases to unlock the key. So now you can see that our Linux machine has now created two keys. One is the private key, and one is the public version of it. Now we will take the public key, add it to the Junos device, and then we'll take the private key and upload it into Ansible AWX. So for that, let's go ahead and cat out home c.ssh and AWX. This is going to be the ugly one, right? A big wall of text is the private key. Go ahead and copy paste if you've got the nerve or the patience. But for us, we'll copy that and I'll revisit AWX. And here I'll just paste it out. And your private key, if you issued it the way that we just did, you should always see the end open SSH private key at the bottom. And at the top, you'll see the open paraphrase for that. Now, the private key passphrase, again, if you add a password to lock your key down, this is where you would need to pass the password. I don't do that, so no issue there. Authorized password is a Cisco thing, right? You know that when you log into a Cisco device through SSH, you get the what do they call it, global prompt, and then to get to enable mode you need to type in EN, and that's where you pass in an authorized password, so separate from your username and password. Juniper, we don't do that silly stuff, so we're just going to go ahead and click save. And now I have a network credential to log into my device. Let's now add the public key to my Juniper device. So let's cat out the awx.pub, and there we go. Let's copy this and let's SSH into a cluster of firewalls here. Am I on the wrong LAN? No, I'm good. Oh, firewall. Okay, and we're going to go into the edit mode, and I'm going to say set system login user AWX. So we're creating a new AWX user. I want to give it King Kong password or privileges. So we're going to pass in super user. And then we're going to say for authorization, we're going to do SSH RSA. And now I'm going to pass in double quotes and then just pass in, paste here the public key within its entirety. And if we did everything right, let's do a show compare. And it looks like we're good to go. Let's go ahead and commit that configuration, which will commit it to our friendly cluster of firewalls. And we will test this out by trying to SSH into these firewalls from our Linux machine. So we'll say SSH-I, and we'll point to our private key. And then I'll say the username is AWX at, we'll just say firewall. Let's see if DNS is working. It is. Type in yes. And I did not get in there. So there's something wrong. Oh, it's still committing. It's committing to both firewalls. So please stand by. All right. The commit is now complete. So now we should be able to hit the up arrow, try again, and voila, we're in the device. So now that we know that the Juniper firewall cluster has my public key, and we're able to authenticate by passing in the AWX user and pointing to the key, the private side from my machine. So there's nothing to concern ourselves with about the inability to log in from AWX. It looks like we've just validated that will work. Let's go back and update our playbook now by telling it which SSH credential to use for the network. So I'll go into the playbook, I'll hit the edit mode, click on the little magnifying glass under credentials. And here we need to change the default from machine to network. Again, remember, Ansible was meant primarily for servers. So they're going to default to things for servers. We need to tell it, hey, we're cooler than the server people. We want to do the networking things. So now I can see that I've got that network credential that we had created. Go ahead and select that and click OK and hit save. Now we still need to add the Ansible execution environment, the thing that's got our packages, our Python packages on it. Because right now, if I execute this, well, one, we don't have an inventory, so that's going to fail. And two, the libraries in the default execution engine are not the ones that we need. So I already have an execution environment available for us to interface with our network source of truth, which in my case is Netbox. Let's go ahead and open up Netbox just to get familiar with the user interface. This is the newer version of Netbox. I'll turn off the dark mode just so that everyone can see it just a little bit easier. Ooh, it's pretty, very nice, very fast. Underneath my devices, I can see that I've got some that are already kind of staged. This is my cluster firewall. If I drill into this, I can see the type of firewall, the serial number, the rack that it's in. I can look at the rack layout to see where it fits within the actual rack. I can see that, yes, this is a cluster. I can look into the interfaces. I can see all the interfaces, all the IPs associated with it, et cetera, et cetera. My entire firewall is now documented inside of Netbox. This allows me now to tell Ansible, hey, if you want to know my network devices, talk to Netbox, right? And it's got all this information, and Ansible will pull in all this information whenever it gets the inventory. So it doesn't just get like the host name and the IP address. It pulls in all the information about the interfaces, all of its IP addresses, all the VLAN information. It pulls in the operating system, the platform, the version, all that goodies gets pulled into Ansible. And now that information will be available inside of my playbook. So really, really powerful mechanism of getting your devices and all the relevant information within them available for your Ansible playbooks. Really, really cool. Okay, so we want to tell Ansible AWX to knock on the door of Netbox's API and say, hey, give me the loot, give me everything that you got, right? And so what we need to do is we need to kind of stitch these things together. So Netbox itself has a REST API, and it has some Python packages as well to help you work with that REST API. So I already have a execution environment for Netbox. Let's see if we can find that. Here we go. So this is a Ansible execution environment for Netbox inventory. So what I want to do is I want to go ahead and clone this back into my Ansible project. So let's actually wait. No, I don't need to do that. What I need to do is pull in the container image. Let's go to packages, container registry. And there is our container image. I'm just going to click on the copy and return over into Ansible AWX. We're now in the execution environment. So we need to add the container into our environment. So I'll click add, and we'll call this Netbox inventory. And for the image, I'll go ahead and paste the name of my image and make sure to pass in the tag. I think the default tag here is going to be latest. So let's make sure we include that as well. Tags just allow you to have effectively safe namespaces. So you can have one image, but millions of different variations of it. But the default will always be latest. Now we're going to tell it the pull method. And I just say, go ahead and pull this container anytime a playbook is looking for this environment. And the organization will belong to Redtail Consulting. And the registry credential, I don't think I need this, but if your container image was private, you would need to be able to pass in a registry credential. We'll see what this actually looks like if we're unsuccessful. Now, the one thing that I don't like about the way Ansible AWX is currently structured, I cannot try to pull this image on demand. I actually have to associate a playbook to this execution environment before it tries to pull it down. This is a problem because if there's an issue with your authentication, Ansible will not tell you, and you'll be sitting there waiting for 5 minutes, and you'll have to figure out by yourself, oh, it can't pull down my execution environment. So let's return to our playbook, go to the edit mode. In this case, we'll now have an execution environment to reference, and we'll say Netbox inventory is the one that we added. Click that select button and hit save. Oh, I'm sorry, that's wrong. That's for interfacing with a Juniper device. That's not the right one. So I'll move that back to its default. We need to now create a new project that will have all of our information about our dynamic inventory resource. So going back up to here into my projects, let's look into, let's look at my projects. I've got inventory scripts, Netbox. So this is passing all the information required for Ansible to interface with my Netbox environment. We pass in the URL of my API or of my Netbox instance. I'm passing in my API token that I generated for Netbox. I'm telling it to disable certification validation because I use self-signed certificates because it's a big hassle otherwise. And I'm telling Ansible some additional information about like how to group devices together, et cetera, et cetera. So for us, what we need to do is we need to now add this repository into our AWX environment. So I'll do a clone operation over SSH. We'll return back to Ansible AWX and say, I want to create a new project. Let me make sure I got this right. Do I do it here? Let's go ahead and create a project. We'll call this Netbox dynamic inventory. And again, the organization is our fictitious one. The execution environment is now going to be the Netbox inventory because that's got the Netbox plugins and Python packages. And we'll again clone this over Git. We'll pass in the URL of the inventory script and pass in our credentials to pull that down and click the save button. And this is going to go ahead and retrieve this project, which basically has two files. One of them is an empty README, and the other one is all the parameters required to interface with Netbox. All right, so that was successful. We pulled down that project. Now we need to actually create the dynamic inventory. So we visit the inventory, we say add a new inventory, and we'll call this yet again Netbox inventory. The organization will be our fictitious one, and click save. Now that by itself was not enough. Remember, we didn't actually associate this inventory to the scripts that we just downloaded from GitLab. What we need to do now is go to the sources. So remember how I said you can statically enter your devices? This is where you would do that. You would go to like groups and you would add like a group for firewalls. And then you would go into host and you would sit here and you would type in like, you know, my name of my firewall and its IP address and blah, blah, blah. But in our case, we're going to pull this from a remote source. So I'm going to go to sources and click add. That's, where am I? Oh yeah, sourced from a project. Oh, I'm sorry. We're going to call this the dynamic inventory script. The execution environment, again, is going to be the Netbox. Sourced from a project. The project itself is the Netbox dynamic inventory project that we just pulled down. Don't worry about this warning. This is one of the cosmetic bugs that I ran into. You just click and it goes away. The inventory file is going to be found in the project root. No need for credentials, no need for any of this other stuff. And we have some options. You can tell Ansible every time this dynamic inventory script runs, go ahead and overwrite everything that was previously inside of your database. I don't need that, so I won't go ahead and require it. Update on launch is kind of similar to another theme that we had talked about. If this playbook, if this script, if this inventory is referenced in a playbook, anytime that playbook runs, make sure to run your inventory first. I'm not going to run that, but there are some cases where that makes sense. Now what we'll do is we'll also incorporate a schedule and say, hey, on every hour, go ahead and execute at the 4-minute marker. So every hour, so like 104, 204, 304, whatever, this playbook will execute. Let's go ahead and set it at 4 p.m., 5:04 p.m. We're in the cool time zone, so that's going to be in Chicago. And we're going to tell it run every hour and to never end, just run every single hour. Go ahead and click save. Oh, the date, the time is they're a little upset about the time. We'll go ahead and add an hour. Okay. All right, so the schedule is now associated to the dynamic inventory script. So every single hour, Ansible will reach out to to Netbox to get a fresh version of the inventory. Let's go back to the sources. And now we're going to run our dynamic inventory script for the first time. Again, looking at the host and the groups, we've got nothing in there. But if we're successful, when I click this synchronize button, let's look at the actual output of this task. What should be happening is that that execution environment for Netbox is going to be instantiated as a container, and we're passing in all the parameters from our inventory YAML file. And now it's going to reach out to Netbox, make all the API calls, retrieve all the information about the devices and groups, and then that will now be available as a source of inventory in my environment. So you'll note that we're kind of not getting any output here. And this is like what I mentioned earlier, the container for the execution environment won't actually be pulled down until you have a playbook that's asking for it. So if we go back to the Kubernetes environment, and we'll have to re-authenticate here to AWX 3, and we'll get the King Kong access of sudo su and kubectl get pods-a for all. This will tell me, all right, we've got an issue right here. You're trying to pull down an image and there's an error with it. And I have a spidey sense that the problem is that the container registry is asking for a credential and we didn't add one for the container registry. So let's go ahead and validate that by selecting the job, copying it to our clipboard, saying kubectl logs, and then we'll just pass in the name of the container. And it says bad request, container is trying and it's failing to pull the image. So AWX is unable to pull down our execution environment. Again, I think this is because of credentials. But as you can see in the GUI, it's going to sit here and it's going to time out after 5 minutes. Really frustrating because you won't know where to go. So while this is doing its thing, let's go back and create a new credential for our container registry. So the credential type is going to be container registry. I'm just going to call this GitLab as well. Organization is Redtail. And let's pass in the necessary container registry information. Now we'll get this from GitLab itself or wherever you're hosting your container images. Let me try to hit the back arrow enough times to get into the right spot. And Netbox inventory, there we go. Let's revisit the login commands required. So Docker login, I'm just going to copy this to my clipboard, paste it in my URL, and there's the registry URL. So registry.gitlab.com is the authentication URL. The username is going to be my username for GitLab. And then the password or token, if you use GitLab, this has to be a token, right? So don't be like me and spend about 2 weeks trying to figure out why your darn password won't work, because it actually needs to be an authentication token itself. So let's go ahead and pull in GitLab. And I don't want you guys to see my super secret password or my super secret token. Let's see, where did I? Please tell me I stored that somewhere. No. There we go. Okay, there's the token, copy, and I'm going to paste it in here. There we go. Click save. Now that we have a container registry token, now we can authenticate to pull down our execution environment. So I'll revisit the Netbox, click the edit button, and now for the registry credential, we'll point to GitLab and click save. Now this job is probably still running. Yep, still running. I think the timeout's 5 minutes. So I'm going to go ahead and click cancel. And then I'm going to click relaunch. And now if we revisit the Kubernetes environment and say git pads all, looks like it's still terminating that job that we had asked for earlier. And now we can see that we're not getting the error image pull, we're getting container creating. So this is good. This tells us that Kubernetes is now able to authenticate with our container registry and is able to pull down the container image that we had built. So this will take, well, let's see how long it'll take. Might take a minute, but now we can rest assured, at least I think we can rest assured, that the execution of our dynamic inventory script will be successful. We'll just go ahead and see if we can monitor this job here, kubectl logs-f. And the name of our pod, and there we go. It looks like it's going through right now. Let's exit out and return back over to here. Now, this is something worth noting. The user interface within a job, you might not get the output the output might not show up immediately. You can either refresh your page. What I'll commonly do is I'll just spam this double arrow down, and sometimes that will force the output of the container job to be put back up here in the user interface. Hopefully someday AWX or Tower, they'll have a better architecture to where it'll automatically appear on demand. But for what it's worth, this job basically tells us everything that the dynamic inventory was just doing. So here you can see it's making a series of API calls. It's getting a list of sites, the regions, locations, any tenants, if you've got multiple tenants, platforms. It's getting all the information that I told it to back in that inventory.yaml file. And now if we go to our inventories, click on Netbox inventory, and if I go to groups, I now have a bunch of different groups. Now it created groups in the way that I told it to, create groups based on site, create groups based on platform, create groups placed on model, create groups placed on the role of the device. So I have a firewall groups, I have switch groups, I have groups based on platforms. So if I click on my firewalls, for instance, and look into the host, I see my two firewalls that I have here. One is an SRX 320. The other is that cluster that we had added the public key to. And if I click into this device, again, it didn't just grab the IP address and the host name, it grabbed all the cool stuff. So every single interface is now has like full information, the name of the interface, the type of like connection, it's copper, SFP, if it's got an IP address on it, it'll have that. If it's got VLAN, here I can see a redundant Ethernet because this is cluster. So all these goodies, this data is now available in any playbook that you execute, right? So super duper powerful, because you no longer have to declare all of your variables for your device. Now, all you need to do is have them available in something like Netbox, and then AWX can now ingest this. And anytime your environment changes, you don't have to revisit Ansible AWX. You would just make those changes inside of your network source of truth, and this information will get pulled on demand. So super duper powerful, very, very cool way of doing things. Big fan. Again, I can look into the rack. I can see where this is positioned. So really, really great network source of truth. I can't overstate rather, how important this is for your automation efforts. If you were starting from ground zero today, September 30th of 2021, and you had no automation in your environment, and you wanted to know where to get started, my recommendation is pick a network source of truth, because it will be the backbone for all of your automation efforts going forward. All right, and if you're interested in that, again, we have previous videos on network source of truth tools like Netbox and Autobot. Really, really awesome. Okay, so what do we have now? We have Ansible Tower up and running. We've got organizations, user credentials, SSH credentials, GitLab projects, PM pulled in here, dynamic inventory being sourced from a remote repository or remote source, in our cases, Netbox. So we've got a playbook as well, but we don't have a container image that's going to be able to execute our plays. So I have one. We created one earlier. Let's not use that one. Let's just stick with tried and true, because we'll be here for another hour if I start going down the wrong path. Let me find my other repository here. Heavens. Ansible Juniper Junos automation. Let's take a peek at what's inside of this execution environment, inside of the requirements.txt. Again, just the standard Juniper packages. Kira asked a question. Okay. All right. Oh, sorry, guys. I've been missing out on your chat. Jason says, yeah, version 3. I don't know what that means anymore. Sorry, it's been 20 minutes since you posted that. Heavens. All right. Sorry about that, Jason. But yes, version 3. Sean says, please show and discuss that dynamic inventory script. Sure, absolutely. Let's pull that back up here. And my projects inventory scripts, where are you? Oh, that's right. So inside of my groups, your groups, I've got a few groups here. I've got one for network source of truth plugins, but that's not what we're looking for. We're looking for, is it under networking? And oh heavens, where are you? Let's automation examples, maybe. Ansible. Nope, these are not the droids we're looking for. Let's go back a little bit. Systems automation, networking. Let's look at this one. Oh, there we go. Inventory scripts. Of course, it's Tom and Jerry. I should have known. And for us under AWX, we've got this Netbox one. All right. So again, we cloned this repository inside of GitLab. This is the backbone of our dynamic inventory. It's just a simple file called inventory.yaml. If you're wondering where to find out the information required, what you would look at would be Netbox, Ansible collection. And there you go. So under the Netbox Ansible modules, there's some documentation here. Let's go ahead and move here. And then you can just look at my browser history, the purple stuff. There's using inventory plugin with AWX and Tower. And this is where I found out, all the parameters that I needed to pass into that YAML file. And so, yeah. So that's how I arrived at this file that you see here. The important ones, again, you need to tell it what kind of inventory plugin. In this case, it's Netbox. You need to tell it where to find your instance of Netbox. In my case, it's this URL. You need to tell it what your API token is. In this case, that's my API token. Disable SSL certifications because I'm a bad kid. Config context. This is an interesting one. Inside of Netbox, you can actually store your device configuration as key value pairs. There are some people that maintain Netbox that will get mad at you for doing this, but I can see a lot of really good reasons that you might want to store config inside of Netbox. I'm telling it, yes, pull down the config as well, pull down the interfaces. And then here's where I told it how to group devices. Again, based on the role, firewall, switch, access point, the platform, SRX 340, 320, device types, tenants, sites, racks, tags. That's what actually created these groups within our inventory right here. These were all created based on these parameters that I told it to pass it by. Query filters allows you to do some filtering. Don't use that very often. This one is really good. Has primary IP is set to true. That means that if you can have all kinds of devices inside a Netbox, but if you haven't associated an IP address to it, then don't pull it into your inventory, which makes a lot of sense for dumb devices, wireless access points that might not have a dedicated management IP. You know, there's a lot of reasons. Yeah, there's all kinds of things. PDUs that might not have an IP. There's no need to pull it into your inventory. Flat and custom fields. I forgot why I selected that. I guess I would revisit the documentation to tell me that. But anyway, hopefully that helps. Okay, Netbox requires manual entry. Yes, no, it does. Well, yes, but no at the same time. So we showed this on a previous session. Let me pull up my Notobot instance, notobot.dmz.home, just because there's a Ubuntu. There we go. All right. There is a plugin that I use for Netbox and for Notobot. I don't have it on my Netbox instance, so I can't talk about it right now. But there is a plugin that was written by a former Juniper employee, Damian Garros, that will actually use Napalm Python package to reach out to your device and pull in information about it, and then automatically add that device into Netbox. So here we can see that we had performed. Here we had a couple of problems. The device wasn't active. Actually, this one, I was trying to do it with CRPD, which wasn't supported. But here we're actually pulling in devices, and you can tell it, you know, and so it would actually ingest, if I click create device, or if this is the result of that, right? So it pulled in all the information about all my interfaces. It pulled in, well, I won't be able to look at LLDP informations or config, but you can have your network source of truth query your network and then automatically associate and build that device inside a Netbox. Or Notobot. There are some really strong opinions about this, not to rehash the network source of truth video, but effectively the maintainers of Netbox have this philosophy that your network source of truth should be what you intend the network to look like, whereas Notobot is going in a different direction, and they're saying what your network actually looks like. I can see value in both of those arguments. I can, you know, depending on what day of the week it is, I might give you an answer as to which I prefer. But again, not Netbox, they're saying this is how it should be rather than this is what it is. And so there's kind of the dichotomy. There's the split philosophy between the two. You can still use the onboarding plugin for both. And if you're interested, I built some plugins for Juniper's Apstra so that you can onboard dashboards and all kinds of good stuff in here. Revisiting the questions, Brian says, how do you upload the config to GitLab once retrieved? Brian, it's been 8 minutes since you asked the question. Which config are you talking about? Is it the YAML config file that we're looking at right here? Because the way that we did that is I just created a repository and I dumped this YAML file inside of the repository, and I just cloned the repository inside of AWX, and that's how I get the data in there. I hope that answers, but if it doesn't, oh, Netbox version 3. Yeah, thanks, Jason. Yes, 100%. I am a huge fanboy of this new JavaScript user interface. So I love what they're doing with that. From the playbook SRX configs. Oh, okay, yeah. Let's get to that. So Brian's question is about how do I pull in the configuration. I'll show you that playbook again. The playbook is it's probably not going to do a whole lot for us in the example of AWX, but it's at least it'll help us understand what's going on. So for the this is the wrong one. The automation examples repository under Ansible. And let's look at the retrieve configuration. What's going on here? I'll look in my files, Ansible, and the download. So this is the playbook that we have now added into AWX. We cloned this repository as a project. Then we created a template based on this YAML file that we're looking at right here. So what this YAML, this is an Ansible playbook. If you've never seen one before, this is what's going to take place. We're basically telling it to create a backup directory within the container. Again, this really works better when it's executed locally so that you can store your device configurations on your computer, but it should work for what we're trying to do as well. So here we're just creating a directory to hold the configurations. I have a variable called device backup directory. It's in my group vars, and it's just like var temp blah whatever. But I just want to make sure that directory exists on my container before I try to put configurations into that directory. The next action is we are importing the official Juniper modules for Ansible. That's going to be inside of my execution environment. And then we run this command right here, this Ansible module called Juniper_Junos_config. And I'm telling it retrieve the committed configuration in the format of text. And don't do a diff, don't do a commit check, and don't commit the device. But save the output, save the configuration as a new variable called committed. And then it says here, we'll just write those configurations to a file. So we'll just see if this executes successfully. But just know inside of the context of like Ansible AWX, this wouldn't be the most beneficial of examples, but at least hopefully you can see the workflow take place. All right. Jason asked, can you provide us with a scrubbed cheat sheet that you're going to use? Oh yeah, absolutely. I will try to paste it in the Zoom right now. No, I won't. That will be terrible. It'll look terrible. Zoom formatting is hilarious. But yes, we'll. Is there any reason why this isn't public right now? I can't think of any reason. So let me go ahead and do this. I will make this repository that's got the tower set up. I'll make this public and I'll just paste the link here into the chat so that you can visit this. Let's see, visibility. This is, oh, I can't because it's nested inside of a private repository. Calvin, you're brilliant sometimes. Let me go back into my networking tab. This is public. Go to automation examples. This is public. Ansible. This is public. Create a new project, and we're going to call this Ansible Tower AWX cheat sheet. All right, and this will be public, and initialize it. And oh, it doesn't like the thingamabopper. We'll go ahead and click create project, and I will paste in the goodies. So we'll create a new file here, and we're going to call this setup instructions. Actually, no, we'll not create a new file. We'll just update the README. That way it's visible whenever you visit this page. And I'll hit edit, and we'll go back over into GitLab, find that project again, cheat sheet, no, Ansible Tower. Let's grab this file right here, and I'll just say, give me the raw, copy, paste, and yeah, that's good to go. Go ahead and commit. So now all you need to do is visit this repository here, and you're going to get my the commands that I used for today, right? So the only one I just want to bring awareness to is this Vim. This is where we created the config file needed to stand up Ansible. I have it separated in here because whenever you issue this command, you're going to need to add in the contents of this file right here. Oh, and obviously the names of the container images will be different because they're dynamically generated. So just be aware of that. Everything else, oh, excuse me, everything else should just be copy paste, and you're off to the races and running. All right, hopefully that helps. Yep, no problem. All right, getting back to the nitty gritty. Sorry, we kind of got diverted there, but we've got a lot going on. We've got a working Ansible environment. We got some projects in here. We got some playbooks. We got dynamic inventory. Did we create the execution environment yet? Not yet. So we're going to create the Juniper container, Junos automation, sure. And the image is going to come from a repository that I have. Where are you? Personal, and all of these are public as well, if that helps. You can just copy my execution environments, and you're off to the races. We'll copy that URL. We'll add it here. And oh, just kidding. Sorry, it's not the URL. It's the container we're looking for here. So we'll copy that container image, paste that there. Make sure that we add the tag. So the tag I'm looking for is this. Oh, is it really that one? Okay, let's copy this tag. I'm surprised it's JSnappy. But oops, there we go. And we're going to tell AWX to go ahead and pull this anytime a project with this container. Just so you know, it doesn't pull down the full container every time. It will only check to see if it has all the right layers or that nothing has changed since the container was published. So although I'm saying pull down the container, it's not going to pull down the full 300 megs every time. It'll just check to see if it needs to. Let's add our credential and click save. All right, and now if we come back up to templates and I edit this one, the last thing for us to do is now tell this one to use the Junos automation container. And I think we should be good to go. I think we're finally ready. After all of that, let's see if we can launch this. Wait a minute, let me do one more thing. If we look back into our playbook, where is that? Retrieve config. I think it's this one. And if I look into this file, you'll note that the host is currently set to all. What that means is that if I executed this playbook right now, this will go against, oh, we need to update the inventory. Let's do that. So we're going to point to our dynamic inventory, which is Netbox, and click save. Now, if I issue this right now, this playbook to download the config will go up against all of these devices. And most of these are servers. So that's not going to be hunky-dory for us. What we need to do is we need to limit it based on one device or a group of devices. In my case, I'm just going to say I want this device to be the limit. So the way that we can do that, we have a couple of different options here within the playbook. I can either hard code a limit to say only run this against this device, or I can have Ansible prompt me whenever we launch the playbook to tell it which devices or which groups of devices to execute on. So I'm going to check that box. And now I'm going to click the launch button. And you can see here, I'm prompted to say, which device do you want to execute this against? And I'll just pass in the name of my firewall and click the next, and then we'll click launch. Now this is going to, again, it's going to try to pull down that Juniper container image because it hasn't existed yet. Let's see, clear the screen and let's look at the pods. And yeah, so we see that the container is being created. This, again, this is a one-time operation unless the container image changes at all. And what it's doing is it's now reaching out to my container repository and it's pulling down this specific image. And once that's done, how big is this image? It's 320 megs. So bigger than a Super Nintendo game, but smaller than a CD-ROM. So let's see. Okay, so now it's actually running. So it's done pulling down the image. Let's look at the task. Okay, so my playbook failed. It says it was unable to authenticate to this, to my firewall, which really breaks my heart because I thought for sure that the username was right and that the private key was correct. That should have worked. Let's validate this again. Let's go ahead and run this directly from the Ansible server just to make sure that everything is kosher. We're going to say SSH to this IP address, actually SSH AWX at this IP address. Yes. The password, we forgot to tell it to use the secret key or the private key. SSH AWX, right? I think that's right. No, it's just IDS or say, where is my SSH key? It's not on this host. We had done it from a different host. Let's come back over to this guy, SSH at code 2 and SSH, clear the screen, ls, lsa in my SSH directory. There's my private key and SSH-I and SSH AWX. The username is going to be AWX at this IP address. Yes, and it logged in. So unable to make PyEasy connection, connect auth error. So it's definitely an authorization issue. It used port 830 for netconf. Is there anything in the firewall policy that would prevent this from working? Let's see here. I think connectivity is ironed out. I think we're good. Feels great to watch you troubleshoot things in your lab environment. I'm happy to know. Yeah. Hey, I spend most of my time troubleshooting. So if you run into problems, don't worry about it. You're going to be okay. So let's do some live troubleshooting. Okay, I'm able to authenticate with the private and public key. Maybe my private key got uploaded incorrectly. Maybe I fat fingered the copy paste job. Let's return to our network credentials and hit edit. And we'll go ahead and clear. So you can see I can no longer revisit. I can no longer see the SSH private key. The only thing for me to do here is to actually replace it. So don't worry if you enter your password, your private key pair, it's not going to be viewable by anyone, even me who has King Kong access. I still can't see it. Let's first do this. Let me try my personal SSH key. I'm sorry, my personal SSH password, just to see if the problem's with the key. So I'm going to clear that out, and I'm going to pass in my username and password instead and click save. We'll go back to the template, and here, actually, let's re-show you that jobs panel that I was talking about earlier. This one's really important. Here I can see, all the successful control or source control polls, inventory syncs are successful. Actually, this should be interesting. Oh, no, we haven't reached the time for the automatic poll. And now I can look into this job and I can say, hold on. Let me just make sure that we did tell it to use the right, network AWX. Okay. All right. So I'm just going to relaunch this playbook now. So we'll click all. And that will reinstantiate the playbook request with any parameters that you may have passed. So in our case, we passed one parameter to limit the inventory. All right. Let's kind of just spam this. Didn't help. Oh, okay. All right. It looks like that was successful. All right. So there's definitely a problem with my SSH key. We'll work on that in just in a second. But I want to point to this because this is the first time that you actually saw a successful Ansible interacting with the network device. So remember, the way that the playbook is structured is that it will first create a local directory to host any configurations. Again, this really helps not when you're just one device, but when you're multiple devices and you just want to have one big folder where you stash them all in. And then we retrieve the configuration. In this case, we're retrieving it as the standard Junos structure. So we call that text. And then we're writing it to a local file. Now, what's really cool about this is that at each one of these steps, each one of these tasks, you can click into it and get detailed log information, exactly what happened in that task. Now, the challenge is that it's going to be presented to you in JSON, but as long as you can read like a machine, then you should be good to go. So in this case, this was the first one where we created the local directory to hold the config file. You can see that, yes, this was the path that was given. Looks like I had an extra slash in there, but Linux is friendly. It doesn't discriminate. So this was where we created the local directory. Okay. Here's where Ansible will reach out and gather some facts about the device. So let's reach out into there. Here we can see some basic parameters about Ansible. Just so you know, the get facts operation doesn't mean anything for network devices. This is a system, Linux server thing, where it basically does a King Kong show version for Linux servers. It doesn't really apply to us. That's why a lot of Ansible playbooks for network devices will say gather facts, that's set to false. So you just don't worry about that step. It only took 2 seconds, so I'm okay with that. Here's the task where we retrieve the Junos configuration. If we look at the JSON here, here's the baby that we were looking for. So this is the Junos config and standard Junos structure. Now, I could have asked for this as JSON. I could have asked this as XML. I could have asked for this as set commands. But here I'm just asking for it in the clear text fashion like I was on the device. So here's my full config. You'll note that it didn't dump the configuration to the console because I didn't tell Ansible to. In our case, I just told Ansible to write the configuration as a local file in that directory that we created in the first step. So that container will now have a file in this directory. It'll have a timestamp or at least for the date, and then the name of the file based on the host name. This allows me to have separation. If I run this playbook every single day across 100 devices, I will have a unique directory for each device, and each directory will have a configuration for where that was in the day that we had pulled it down. So that's how I structured this. But you can still see the output of the task as long as you just click on that specific task. And here you can see, yep, we got the goodies. So we're good to go. All right. So let's revisit the SSH keys, because that's going to bother me. I'm not going to be able to sleep tonight if I get this, don't get this right. So let's exit out of here. And let's do this. Let's from my local machine, let me do a secure copy for this user at this host at this path of c.ssh and then AWX. And I'm going to put this in my var temp directory on my local host. All right, and then we'll do the same thing for the public key. All right, so now in my local machine in the var temp directory, I should have two files that start with the phrase AWX, and that's one is my private key and one is my public. The reason why I secured copied it to my local machine is that now that when I use the web browser, I can just point to a file on my local machine and it'll upload it rather than waiting for me, or rather than expecting me to get my copy paste skills on par. So I'm going to remove the password and I'm going to add back the username as AWX. And now, since the key is on my local machine, I can just click browse and change this again to var temp. And here I can point to my private key, which is this one right here. And there we go. That looks good. Click save. And let's go back to the jobs and let's just execute this again. Now this should be based on the AWX user instead of my other username that I had hard-coded in there. And so you'll note that there's a delay, right? There's a couple of things that are taking place. One, the container image is looking to see if it needs to be updated, which it didn't. And the other is if I authorization issue, unable to make the PyEasy connection. Ladies and gentlemen, just use username and password. I'm trying to be fancy over here and use SSH keys, and obviously there's an issue with it. I don't know why. That should totally work. We validated that. I'm just not going to worry about it. But at least we got a good message out of it to say, hey, there's a connect authorization issue. But you know, just use username and password. You should be good to go. Hopefully that doesn't detract from this. Let's see. What else did, oh yeah. Okay. So, all right. Now we have a fully working Ansible AWX environment. Yeah, it took about 2 hours to stand up and talk through. Actually, about an hour and a half. The first 30 minutes were me just ranting. Now that we have a working Ansible AWX environment, let me go back to using username and password for AWX. I actually have a user inside of my home called Ansible. We'll clear this out, and for the password, I will pass in my super secret one. There we go, and pass this. Okay, that should work. And that should work. And let's try this just one more time. Now that we've got everything situated in the way that we think that it should be working, let's go ahead and relaunch this. This should now use my home local username, Ansible. Oh, heck, I should probably validate that user is Ansible at 192.168.104.1 and pass in that password. Oh, I don't have that user on there, do I? I don't. Okay. Let's go ahead and log into that firewall and add that user. We'll get this, I promise. SSH into my 192.168.104.1. And let's look at the users that are on my firewall right now. Show configuration, system login, display set. And I got the AWX. Oh, that's using a different key. That's why. Okay. So let's update the Ansible user, set system login user. Oh, that's right. Okay. Delete system login user Ansible authorization SSH RSA. And oh, don't make me do the whole thing. Come on, be cool. Okay. Statement. All right, we're just going to delete the Ansible user. We'll recreate it. Set system login user Ansible class super user authorization plain text password. And let me again paste in this. Bippity bop, boppity boop, show compare. Yep, we're removing the SSH key and we're now going to default to a password-based authorization. That will then allow this to execute successfully once the configuration commit is applied to the cluster of firewalls here. That was the AWX key. So I know it's confusing. I had an AWX key for the AWX user, and I also had a local user called Ansible, which had a different AWX key. This is the problem. Like, you guys don't understand like that there's a ton of prep work that goes into these things. And I tried like, I thought I had this rock solid, but at the last minute, I ditched a lot of things. And so there's a lot of config bloat across this users. So I apologize for that. Commit complete. Let's go ahead and run this again. This will use the username of Ansible with the password that I have on this host. Again, the output doesn't show up immediately. Just be patient if you can. There we go. Okay, so now that works. All right. So really cool. We're in a good position now. We're executing playbooks. Yeah, we're not really doing a whole lot, but we're just pulling down a config and writing it to a local file. But the workflow would be the same if you're pushing config changes to the device or anything else. Now, let's talk about that API on Ansible, because this is huge. This is killer. We have the capability now of issuing playbook executions through the API. And so the way that we'll do this is, let me close out all this garbanzo beans and let me move to API/v2. So this is the REST API documentation for the Ansible environment that we have set up here. So I can see some things that I can do. What I'm looking for is something called template. Oh, just kidding. Control F. Templates, job templates. All right. This is the magic one right here. These are, remember, templates are your playbooks, right? So let's look at the API for templates. And here I can see that we've got a few options available for us. One of them is the Netbox inventory. Looks like this template right here. Actually, let's go back to the UI and find the template that we're wanting to execute on demand. And I'll show you how to build like an integration to something like ServiceNow within just a couple of seconds. So let's go back to our templates. If I hover over this at the bottom left of my screen, I'll see that my job template for this is the number 9, just like the Beatles song. So if I click on this again, the URL also kind of reinforces that this job template has a unique ID of number 9. So if I want to execute this through the API, either through Slack, through Teams, through ServiceNow, whatever, I just got to remember this playbook is playbook number 9 so that I can craft my API call accordingly. So let's go back over to here. This is the job template is number 9. And here's all the parameters about this. Now, if I want to execute this, I'm going to call the API for launch. And this will allow us to actually execute this. So let's make a small modification. Instead of prompt on launch, I'm just going to pass in that firewall name, Juniper SRX Garage 1. I just don't want to have to pass it in or through the API for the purpose of today's conversation. All right. So now I'm going to pull up my trusty Postman. I think we've done quite a bit. Yeah, we did a dedicated video on REST APIs, and we talked about Postman and how it allows you to basically use this software as a client for an API. I've got some workspaces. One of them is for, let's try Ansible Tower. Okay. And here, let's go ahead and say template. This is a good enough starting point. So I'm going to just duplicate this task. I'm going to change it from a get to a post because we're going to actually execute. I need to also pass in an updated URL. So I'm just going to copy the one for my playbook launch right here, and I'm going to paste it into here. Now I need to pass in an authorization. Let's show you what it looks like. If I execute this right now, and I'm just going to remove this header right here. If I execute this right now, Ansible will come back and it'll say the API will respond to Postman. I don't know if you guys can see this. I'm going to change it from dark mode to light. My eyes are going to burn. I hope yours don't, but hopefully it helps read it just maybe a little bit more. Okay. All right. So the information we got back from Ansible's API is it says, hey, look, you got a 401. We know HTTP 401 codes are for authorization issues, but in case you didn't know, you could hover over the response and get that data. And it says, listen, we know that you're trying to do this API call and it's a valid API call, but the problem is that you didn't pass in your authorization. So what we can do is we can create an authorization token for us to issue these commands. So let's go back to our users and let me log out of admin and log in as my personal user. The reason why I'm doing this is that you cannot create personal admin or personal API tokens as a user unless you're logged in as that user. Even though I was logged in as admin, I still couldn't create a user credential or an API token for my user C dot. I actually have to log in as that user. So let's go back to the users and click on mine. And now you can see I have a section here called tokens. Let's go ahead and create a token. You can leave the application blank. Believe it or not, that's not an issue. If you leave it blank, Ansible Tower will think that you're creating a personal access token, which is exactly what we're doing. So we're going to call this description is personal access token for C dot. And the scope is either read or write. I usually choose write because, again, King Kong, want all the things. Let's go ahead and hit save. And this is my personal access token. It's only available right now. So call now, right? I cannot revisit this page later and get this API token. So it's really important that you go ahead and copy it right now. Now, if we go back to our our Postman, now I have every bit of information I need to authenticate. I need to tell Postman how to authenticate though. So I'm inside of the headers section. Actually, let's backtrack. There's two ways I can authenticate with the Ansible Tower API. One is if I go into this section called authorization, I can then in here pass in basic auth and do username and password. This would be my login for logging in into Ansible Tower. This is not the preferred mechanism. They prefer you to use an API token rather than passing your username and password, especially if you're just using HTTP, right? Anyone on the wire can capture this packet capture and figure out what my username and password is. Don't be that person. So I'm going to remove this from authorization, and I'm going to instead go over into the headers. And inside of my headers, I'm going to create a authorization key, and the value is going to be equal to the API token that we just created, but prefaced with another word before that. So it's going to be bearer space and then the token itself, right? So this is an OAuth token. There are other types of API tokens out there, like for Mist. You would not use a bearer token. You would just use a standard API token. The reason why I point that out is that the keyword or the word here would be token space, and then the value of the token. But in an OAuth situation, like what Ansible is using, we say bearer space and then the name of your token. I know it's confusing. I stumbled upon this for a very long time until I figured it out. But just know that, yes, there's some small variations here. Now, when I click send, now I get a 201 response back saying the job was created, and I get some additional information about the job. Let's go return back to Ansible Tower though, and go to the jobs panel here. Now I can see the job is currently running. So we actually executed an Ansible playbook through the REST API, and it's going to have the same results 100% of the time. So that's pretty gnarly. What if though, like, so yeah, we're using Postman, and yeah, we can execute it through the API. It's really cool. But what if we have an instance of something like ServiceNow? All right, so let's access my developer instance of ServiceNow. And in case you're curious, yes, you too can have your own instance of ServiceNow. It doesn't take that much to spin it up. It's completely free. Doesn't require a credit card. You just have to get comfortable with the fact that ServiceNow will shut it down every once in a while, and you'll have to kind of kick it back up into gear. And yeah, it's free, so there's no SLA. So yeah, so just deal with the performance issues. But it's a great way to learn ServiceNow. All right. Okay. So inside of ServiceNow, I'm going to create a REST message, and I'm going to tell it to interact with my Ansible AWX environment. So let's go ahead and create a new REST message here. We're going to call this AWX test because my originality is faulty right now. The API endpoint, this is going to be my public domain name. Please don't be mean to me. I think you and I were pretty cool, right? Don't hack me, man. If Zach's still on this call, Zach, please leave me alone. I also need to update some port forwarding rules to allow this to happen. Now, if you are a ServiceNow customer, you don't have to do port forwarding on your public firewall. Obviously, that's the bad way of doing things. You don't want that to happen on an internet-facing circuit. However, you can use what they call a mid server, which will allow ServiceNow to interact with stuff within your environment without doing port forwarding. Basically builds a TLS connection to ServiceNow, and then you can send your API calls or whatever you're doing to this mid server, which then can access your home environment. Me, I just haven't gotten around to doing that. So I'm going to do things the old fashioned way. So show display set grep ServiceNow maybe. Let's try AWX. All right, there we go. So I need to create a new object for, let's create AWX1. There we go. Let's go ahead and do some magic over here. I need to update my firewall policies to allow this communication, so please stand by. I'm going to use the always amazing Visual Studio Code for this because there are plugins to help you read Juniper configurations. Fantastic. Great job, Microsoft. You guys are awesome. Anything that says AWX1, just go ahead and update with AWX3. And bippity bop, boppity boop. There's some things that are a little bit wrong here. We'll need to change this to say the rule is AWX3. We'll have to revisit that. The port number, what was the port number on us? It's 3194. So we'll update that. We'll need to make a new destination NAT pool. So that's good. That's good. That's good. The IP address, one ping AWX3. That's my IP address. So we'll update this as well. Right here. Destination NAT port, blah, blah, blah. No, we'll go ahead and get rid of that rule. And we might be good to go. I think we are, because I think I have everything else set up. All right, so we'll do a load set terminal and just dump in the commands and commit check real quick. Let me make sure. I think there's one other thing. There's one other thing I have to update. I think I have some custom application set that I need to add this to. Okay, let's go ahead and commit it in the meantime, and we'll just test it out from the remote side. So here we're going to do the port number again was 31941. And the API call, go back to Postman, was this right here. So /API, oops. Capture that. And there we go. That looks good. Authentication type, we're going to leave that alone. HTTP request is going to be content type application /JSON. And then the header, like we knew for authorization is going to be bearer, and then the name of our, or the value of our token, which was this right here. So we'll just copy that. And there we go. All right, and we'll just go ahead for now and click submit. Now that the AWX test is here, what we need to do is actually, let's just do a default get to see if we can actually get a positive message. This will validate the firewall policy that we just tested. So we did a get and we got a status of 200 back. So the port address translation and the firewall policies that we just created on the firewall are now allowing this communication to take place from the public internet with ServiceNow. We are now able to interact with our AWX that's hosted internally. So the only thing that I'm going to do is I'm going to create, instead of a get, which just gives you the information, we're going to create a new method. I'm going to call it execute. And this is going to be a post. And we'll just click submit. And now when I click this execute inside of ServiceNow, click execute, I got a 201 back. And if we go back to our jobs here, now we can see we are running it. And this just issued less than a second ago. So that's how you can build integrations into your Ansible Tower. You no longer have to visit the user interface after you have it set up and provisioned and working correctly. Now you can actually have other API clients like ServiceNow, like Slack, like PagerDuty, whatever, Postman, or if you just want to issue this from Python, now you can issue your playbooks on demand. And yeah, you can pass in additional parameters into them and what have you. But hopefully that kind of like integration point makes sense and why it's so powerful to have an API on top of your automation framework. All right. So let me revisit the PowerPoint deck here. The config details, the SSH details, yep, Netbox details, GitLab or GitHub details. Let's go back to the table of contents and make sure we covered everything. So we started with the vanilla instance of Linux. We made the recommendation to discard Ansible's recommendation of using Minikube and instead use Rancher. It's significantly better. So we installed Kubernetes. Then when Kubernetes was installed, we downloaded the operator for Ansible AWX. And again, the operator is just there to provision your Ansible environment. Then we created a YAML file, then passed in some very basic parameters, basically your host name of your AWX instance. And then we passed that file into the operator, and that stood up our Ansible environment. Then we had to find out the port that it was exposing for port address translation. So we did the kubectl get service for that, found the port number that translated to the port 80. Then we had to find the admin password. So we did the kubectl get secrets, and we had to outcode the decoded base 64 encoding on that password. So we got that. We logged into Ansible AWX. We set up the environment by creating the organization, creating the users, creating all the credentials, creating all the Ansible execution environments for both Netbox as well as the Junos. So we showed you how to build those. Hopefully you don't have to use those. You can use the ones that I have in my repository. Again, they're public available. Then we connected it into Netbox, got all of our inventory, not just the inventory, but also like all the information that Netbox had on our devices. That information is now available inside of our playbook, and we can summon it as needed, if needed at all. And then we executed the playbooks through the REST API. So we showed you how to build the personal access token, showed you how to use the authorization header inside of a API call to pass that token in as a bearer token. And then we showed you how to even go end to end by building the integration to something like ServiceNow. So we're about 37 minutes over. I'm not that surprised. This is a big topic with a lot of problems that can peak up anywhere you go. And honestly, like again, I've been playing with Ansible Tower for 4 or 5 years now. I've gone through all the iterations of the install process. I feel like I know it better than anyone else that I've met. And that's not bragging. In fact, I would say it's almost a negative, because I'm always pulled in whenever standing up Ansible is involved or building network dynamic inventory is involved. There's a lot that goes into this. You have to be good with Linux. You have to be good with containers. You now have to be decent with Kubernetes. It's a big ask. I totally get it. And so hopefully, like, having a recorded session like this can be something good that you can, revisit on YouTube later on and help you kind of get off the ground and running. We did run into some problems around authorization with my SSH key. I don't know really what's going on with that, but that's a minor thing, not too big of a deal. Before we wrap up, let me see, does anyone have any other questions? I think we're much trimmer than we were when we started this call. Thanks. Gosh, you guys are gonna make me blush. Yeah, so any questions at all? If not, the remaining 9 of you, let me just thank you for hanging out for the last almost 3 hours now. This is always fun. I love these sessions. I know it takes a lot out of your time, This is why I host it on the last Thursday of every month, to give you a break from the work week. Hopefully you don't work tomorrow. Maybe you do, but hopefully you got a few hours out of your workday to learn something that's pretty cool. If you all have any suggestions on what you'd like to learn next, what October, November, December automation workshops are, please let me know. If you want to revisit Ansible, if you want to revisit Python, if you want to do a little bit deeper dive on those topics, please let me know. I'm always open to suggestions, or else I'll just come up with it just a week before. And but anyhow, again, everyone, this video will be uploaded to the YouTube channel. I'll just paste it in the chat, just because selfish promotion shouldn't be surprising coming from a sales guy. Let's see here. We'll upload that probably tonight, so it should be available tomorrow afternoon. But if you don't have anything else, again, thanks for hanging out. I really appreciate it. Please send me any suggestions that you might have for the next session, and enjoy the rest of your week. Goodbye, everybody.